Welcome to our fourth lecture of the machine learning series, in which we are going to cover the code part of the logistic regression algorithm by using a popular library known as scikit-learn. So first let's import some necessary libraries. Seaborn. First, we are going to import seaborn as SNS. Import pandas as PD. Sorry for that. Import numpy as NP. So let's discuss what are these library used for in this particular session. In this particular session, we are going to use seaborn for the dataset. In this lecture, we are going to use the iris dataset, which is available in the seaborn library. We are also going to use pandas library for maintaining that dataset, for editing that dataset, and for various other reasons. And we are going to use numpy for calculations. So let's first import the dataset. So df is equal to sns dot load underscore dataset iris. So what this piece of code does is it loads the dataset into a variable named df. And now what we are going to do, we are going to see the top 5 rows of this dataset. Yeah. So as you can see, here are the top five, sorry, these are the columns. Here are the top 5 rows of the data set. There are, as you can see, there are four independent variables and one dependent variables. So first let's check how many unique species are there. So df species dot UNIUUE. So this returns the unique species that are present in this data set. So as we can see, the three unique species are Setosa, versicolor, and Virginia. Pardon my pronunciation. So as we know by discussing the previous lecture that logistic regression is mainly used for binary classification. So we have to remove one of these three species. So let's remove Setosa. So first we are going to select the species column, species not equal to Setosa. Spelling is correct. Oh, sorry, I have not put it in single quotes. So let's put it Setosa, right? And then we are going to put it in the df brackets. So now it will print all the rows in which species are not equal to Setosa. So let's check. Yep, it is doing that. As you can observe, from 1 to 49, all the species were Setosa. From 50 to 100, all the species are versicolor. And from 100 or 101 to 149, all the species are virginica. So as you can observe, all the species that were Setosa are removed here. So let's update our DF, which is our data frame or data set, can call anything, to this. Okay. So now, as you can see, this has been updated. So now, if now we print df.head, if you don't know df.head is a command which is a pandas command which prints the top 5 rows of the dataset, right? So earlier, as you can see, all the species were Setosa and the ranking were from 0 to 4. But now, as we have discussed earlier in this particular lecture only, all the species that were Setosa are removed. So, yeah. So now what is our next job? Our next job is to map the species versicolor 0 and virginica 1. As this is a linear regression algorithm, mathematical algorithm, and maths only understand numbers. Sorry. So first select species, species dot map. We are just changing. Let me just explain it once again. We are just changing. For example, here it is written versicolor. Instead of versicolor, in the next data frame that we are going to print, it will print 0. Or in the place of Virginia, it will it will print 1. Or you can do vice versa also. It is completely good. So first, for CCOLOR, color 0, and similar we are going to do for, let's print here df.tail also. df.tail. So what df.tail does? df.tail prints the bottom 5 rows of the dataset. So as you can see, the bottom 5 rows are printed here. I just did it because my spelling are very, what you can say, are not correct most of the time. So I just printed it to verify my spelling. Verify my spelling. VIRGGINICA 1. Yep. And I think so it is done. I haven't updated the DF, so let's update the DF. No, I don't think. Let's see it. Is it necessary to update the DF or not? Because yeah, it is necessary to update the DF. So let's update DF of uh, DF of species. Is my spelling correct? SPECIES. SPECIES. Yeah, is equal to, and now it is updated. And now let's print df.head, and now you can see instead of versicolor it is printing 0, and if we print df.tail, which prints the bottom 5 rows of the data set, it will print 1. So now the most of the part of the filtering the data set is completed. Now what we have to do is to divide this data set into independent variables and dependent variables. So as you can observe, or if you haven't, you should observe, these lengths, these columns, for example, sepal length, sepal width, petal width, are all independent variables, and this species, this column is dependent on all 4 columns. So let's divide it. So x is equal to df dot iloc. If you don't understand, if you don't know what is df dot iloc, there is no, what you can say, there is no necessary to panic. I will explain it. First, let me write the code. Alloc -1. First, let me check it. Head and y dot head. Yep. So what this df dot alloc does? It is a pandas command. So what it does, it since you can see in a bit before this semicolon and after this semicolon, we haven't written anything. This means that all the rows will be included in X. Similarly, we have done here. We haven't written anything previous this semicolon, and we haven't written anything after this semicolon. So all the rows are included, which are in our this data set, filter data set. So as you can see, all the rows, you cannot see, sorry for that. Let me print its shape. X dot print x dot shape, print y dot shape, print df dot shape. Let's print the shape. As you can see, the number of rows are constant in all the fours. In our original data set also there are 100 rows. In our dependent variable rows are also 100, and our independent variable rows are also 100. So we haven't tampered anything with the rows. We have tampered with the columns. Let me tell you what we have done. Now after this comma, this is the range for the number of columns. Okay. So if we write -1 here, this indicates all the columns leaving the last column. Okay. So as uh, so yeah, all the rows leaving, all the columns leaving the last column. We can also write here the starting column and the ending column here, but this is more convenient as we leave, as we want only the last column. We don't want any column between it. So yeah, you can also write -1 here. And by chance, if you want, if in your data set, in the data set that you are training, there are two independent columns. So instead of writing -1, you can write -2. But here there are only one dependent column, so we have written -1. Yep, I think so that is clear. Ah. So we have distributed our data set into dependent variables and independent variables. Now what we are going to do is dividing this data set into train test split. So what is train test split? It is the usual practice in machine learning that is 80% of the data that is present with us, that is present for training. 80% of data goes to the training of the algorithm, and 20% of the data is used to test the algorithm whether the algorithm is working fine or not. If the algorithm is not working fine, we will look if we are using the correct machine learning algorithm, is there any problem with our data set. Okay, and n number of problems can occur if our accuracy or our accuracy parametric is wrong. So now what we are going to do, we are going to use our sklearn library. So from sklearn dot model underscore selection. First, there is a disclaimer. I'm going to write the code first, and then I will going to explain what code actually means. Import train underscore, sorry for that, underscore test underscore split x underscore train, comma x underscore test, comma y underscore train, comma y underscore test is equal to train underscore, sorry for that, underscore test underscore split x comma y, sorry for that, y comma test, and sorry for that, test underscore size is equal to 0.2, random state random, yes, state is equal to none. For now, for this lecture, you can leave what is random state. That does not concern this lecture. Yep. So now let's discuss sorry for that. Now let's discuss what is train test split. What this particular line of code, yeah, what this particular cell is doing here. So it is taking our independent variables and dependent variables and breaking it into four variables. So what are these four variables? X train, all the data that is going to the training of the algorithm, all the, or you can frame it like all the independent variables that are going for the training of the algorithm. Here you can X test means all the independent variables that are going for the testing of the algorithm. And similarly here, Y trains means all the dependent variables that are going for the training of the algorithm. And Y test, similarly, like X test mean all the dependent variables going for the training of the algorithm. No, sorry, not training, testing of the algorithm. Yep. Leave the random state for once. And here is our features, independent features, and here is our dependent column. Don't worry about features. Independent column and dependent column. Now, what is test size is equal to 0.2? What this does is it distribute, for example, it is not for example, in our data set, there are 100 rows. Okay. So in the training set, 80 rows goes to the training set and 20 rows goes to the test set. If we write here, for example, instead of 0.2, 0.3, then 70% of the rows goes to the training set and 30% of the rows goes to the test set. Instead of rows, the 70% of the data would be a better term, but yep. So after running this cell, now let's print the X train shape so that it is clear to you. Let's print the shape of the X train dot shape. Now, before running this cell, I want you to guess what will be the shape. I hope so. You have paused the lecture and guessed the shape. If your answer is 80, 4, oh, sorry, this is 0. This is good. So you are correct. One more question. Guess what will be the shape of this? What will be the output here? This output prints the shape of the X test. Okay. Pause the lecture and Find it out. I hope so. You have paused the lecture and find it out. And if your answer is 20,4, then you are right. Yeah. Similarly, you can do for y train and y test. If you want, I can do it for you. Y underscore train dot shape train. It will be 80, comma. Yep. And y underscore test dot shape, it will be 20, as expected. Yeah. So our data set is split it down. Now what we are going to do, we are going to import the logistic regression algorithm from, you guessed it right, sklearn. The from sklearn dot model underscore selection, import logistic logistic. I hope so. My spelling, yep, my spelling is correct. Regression. Yep. Oh, there is little bit problem. Oh, sorry. There will be not model selection. There will be linear model. Linear underscore model. If you are having trouble, some trouble, it is not necessary. It is expected. So if you are having some trouble decoding what is sklearn, you are welcome to go to its documentation. Just simply write sklearn documentation. The first or second link will guide you towards the sklearn documentation. And if you write sklearn space logistic regression, then it will guide you to the specific documentation of the sklearn in which the topic of logistic regression is mentioned. Yep. So this is working particularly fine. So let's initialize our model first. As you know that all the code written in the modules, for example, sklearn, numpy, pandas, are written in OOPS, object-oriented programming system. Yep. So let's initialize our model regression. Sorry for that. Yep. Now what we are going to do, we are going to train this logistic regression model. So model dot fit. Fit. Now we are going to pass x train comma y train to this model dot fit y train. So what this particular code does. So as we have discussed in the previous lecture, we have discussed all the mathematical intuition of the logistic regression. Behind this code, it does all the code. It does all the process of that we have discussed in the previous lecture for you. Yep. Now we are going to model dot predict. Predict. Model dot predict. It was, I think so, model dot test. Or no. It was, I think so. I'm not particularly sure. I just forgot. It was predict or test. So as you can see here, our logistic regression model is trained. So model dot predict x underscore test. Yep. These are the predicted value according to the logistic regression algorithm that we have trained on our test data set. Okay. Now we are going to calculate the accuracy score of this algorithm. So from we are going to import sklearn dot metrics, import accuracy underscore SCORE score. So we are going to write, see, these AI does a lot of thing uh, easier for you. Sorry for the spelling mistake, but it cannot correct at least my spelling. Accuracy underscore score y underscore test. Uh, comma, yep, x underscore test. Instead of writing x underscore test, you can put y predicted. Predict. AI is not always optimal. It is almost correct, but it is not always optimal. So instead of writing model.predict x underscore stat, we can write here y pred. Yeah, y predict. Yep, vibrate. We usually write vibrate, so I will also prefer writing vibrate because it soothes me. Let's print the accuracy score. Print uh, accuracy score of logistic regression. Boom. And then we are going to just put this piece of code inside the print statement. Simple. And as y pred is O, I think so. We have not run this cell after updating the, what you can say, after updating the something, this 30th number cell. So as you can see, our accuracy is coming 85% and our logistic regression model is trained. So this is the complete lecture, all the coding intuition using sklearn of the logistic regression. So I hope you have practiced along with me this whole session. I hope to see you in the next video soon. Till then, take care. Bye bye.